Alright, lesson 15, since there's not a checkpoint, we'll go through the workbook questions. And we'll just start with question 1 on this one. So I have the notes up again in the left side of my screen to use as a reference, and I am modeling how, as a student, would I use these to help me with the workbook questions. So question 1, read the proof below carefully, then fill in each blank with the best answer. So given ABCD is a parallelogram, prove any two consecutive angles of ABCD are supplementary. Okay, so the first question I'm asking myself is, what are consecutive angles? That means in a row. So BC is in a row, angles C and angle B are in a row, angle B and angle A are in a row, angle A and angle D are in a row. What's not in a row is angle D and angle B. So consecutive is just from one corner to the next. And then supplementary means they add up to 180 degrees. Okay, 1. The quadrilateral ABCD is parallelogram by definition. AB is parallel to CD. So AB, A to B, is parallel to CD because parallelograms have opposite pairs of lines that are parallel. So then it follows that AD is a transversal of parallel line segments AB and CD. Okay? So transversal right here between these two lines, which makes angle A and angle C same side interior angles along parallel line segments. Okay, so we have angle A right here and angle D. That's the ones that they were comparing, which are same side interior. And then what do we know about same side interior? We know that they're supplementary. Okay, so that's just food for thought in the back of our head. So we know that angle D and angle A add up to 180 degrees. So likewise, step 3, BC is a transversal of these are still the same parallel lines. I'm just drawing them in a different color so we can emphasize it. So BC is our transversal now that we're looking at. And so angle B and angle blank are same side interior. I would say angle B, same side. That means it has to be on the left-hand side of our transversal, and it has to be inside, so they're talking about angle C. So capital C is for our first blank. Therefore, applying the same side interior angles theorem, it is possible to conclude that angle A is blank to angle D and angle B is blank to angle C. They are supplementary. So it is possible to conclude that angle A is supplementary to angle D and angle B is supplementary to angle 1. The other thing we could check is for the same side interior angles theorem. So I would be looking for same side angles same side interior angles. In the left-hand column. So we have interior angles. Maybe I skipped it. Oh, okay, same side interior example proof. So it's coming up. Alright, so same side interior angles. If two parallel lines are cut by a transversal, then the same side interior angles are supplementary. So yes, we were right. They're supplementary. So using the same line of reasoning, but instead consider that AD is parallel to segment blank. So now we're going to use this same kind of logic, but now we're going to consider the other side of the parallelogram. AD as our parallel and CB as the opposite side. So the AD is parallel to segment CB, so comma CB. And these parallel lines are cut by transversals. So here's our first transversal, BD. And again, it makes all same side interior angles right there. Those are supplementary. So there's our consecutive angles. And then the other transversal would be AB. Again, these are our same side interior, which these are supplementary consecutive angles. Okay, and so we've proven it. We've proven the first one, A and D were consecutive in our first diagram. Now D and C are consecutive and they're supplementary by the same side interior angles. C and B were proven to be supplementary, same side interior, and then now B and A, just based on parallel lines and their transversals. Okay, question 2. Read the clue below carefully, then fill in each blank with the best answer. Given ABCD is a parallelogram, prove that angle A is congruent to angle C and angle B is congruent to angle D. So we want to prove that this entire angle made up of angle 2 and angle 3, and this entire angle made up of angle 1 and angle 4 is congruent. And then we want to also prove that angle B is congruent to angle D. Alright, so let's read through this proof. Given ABCD is a parallelogram, prove step 1. The quadrilateral ABCD is a parallelogram, so by definition, side AB is parallel to side length CD, and side AD is parallel to side BC. So in diagrams, you'll see chevron markings, and that's how you indicate which sides are parallel to what. So these two sides have 2 chevron markings. That means they're parallel to each other. And these 2 sides that have 1 chevron marking means it's parallel to those ones. The blank theorem then supports the conclusion that postulate 0101 allows the construction of AC, which is a transversal of both sets of parallel lines. The blank theorem then supports the conclusion that angle blank is congruent to angle blank, and angle 3 is congruent to angle 4. Okay, so they constructed this diagonal. And we want to know what theorem supports this conclusion. And our clue here is that angle 3 is congruent to angle 4. So I want to compare what angle 3 is to angle 4. And to me, I'm looking at this, it looks like alternate interior angle theorem for angles 3 and angle 4. And if we're comparing the other two angles, angle 1, here's the parallel line and the transversal. Here's its parallel line and that same transversal. And if I looked at this angle, they're alternate sides and they're inside this box. So they're alternate interior angles. So the blank is alternate interior angles theorem concludes that angles 1 and 2 are congruent. 1 and 2. By the reflexive property of congruence, side length AC is congruent to itself. Yes, reflexive I think of as reflection, and since AC is itself, that's a reflexive property. That's how I remember it, at least. Okay, so therefore triangle ABC is congruent to triangle CDA by the angle-side angle congruence theorem. What angles were they talking about? For angle-side angle, in triangle ABC, in this triangle, ABC, the angle and its corresponding part, angle in ADC, that they are talking about for angle-side angle, we had angle 2. Its corresponding angle was angle 1, the one that was the exact same measure. There's its angle. The side that they're talking about is the side that they share, AC. And then the last angle that they're talking about is angle in ABC was angle 4, and its corresponding angle is angle 3. So we had an angle aside and an angle match its corresponding angle side angle in the two triangles. So that's our angle-side angle congruence theorem. And then statement 6, since corresponding parts of congruent triangles are congruent, we may conclude that angle B is congruent to angle D. That's because they are corresponding parts. So angle D and angle B are congruent. To prove angle A is congruent to angle C, follow a similar argument beginning with the construction BD. So to prove the second half that angle A now is congruent to angle C, we would follow the same reasoning, except for we would split it this way and make our 1, 4, 3, 2 angles right there and use them that way. So it's the same steps all over again, except for now we did it with D and B. So the last step from Marissa Peer's rejection, you say, well, while we're sharing our statements, just know that critical people reserve the most criticisms for themselves, and they just project on the outward what they are feeling about themselves. So you're just sharing with me and anyone else who's hearing how you truly view your criticisms about yourselves. So that's the 5th step in how to avoid rejection by Marissa Peer. So anytime someone shares a statement and you feel in defense, like you have to come back with a response, you can come back with one of these 5 statements. And you cannot say the 5th one with sarcasm. it has to just be monotone, so there's no, it's not feeding this fire. Question 3. Read the proof below carefully, then fill in each blank with the best answer. Given ABCD is a rectangle, prove that the diagonals AC and BD are congruent. So we want to prove that they're the same length. So since quadrilateral ABCD is a rectangle, it is also a parallelogram by definition. So that means we know that DC parallel to AB and AD is parallel to CB. Since opposite sides of parallelograms are congruent, AB is congruent to DC, so that means these lengths are also congruent. So AB, and to mark congruencies, we use tick marks. So AB is congruent to DC, and AD is congruent to DC. So that's the helpful information here. By definition of a rectangle, the angles of a rectangle are all blank angles. They are all right angles. And right angles equal 90 degrees. So the reason I know that it's a right angle is right here. It's marked in a square. Okay, thus angle A is congruent to angle B due to the right angle theorem. All right angles are congruent to each other because they all have a measure of 90 degrees. Then triangle DAB is congruent to triangle CBA because of the blank congruence postulate. So what do we have here? What triangles are we looking at? We are going to look at triangle DAB, D to A to B. Okay, so we're looking at this triangle right here, and we're going to compare it to triangle C to B to A. C to B to A. Okay, we're comparing it to this triangle. So I'm going to draw these two triangles just over here. CB had the 2 tick marks, BA had the 1, and the 90 was right here. CBA. And then DBA, I'm just pulling it apart so it's not overlapping. This is B, this is A, this is Z, and this was the 90-degree angle. This had the 2 tick marks, this had the 1 tick mark. Alright, what do we have? We have corresponding side, the 2 tick mark, congruent with its corresponding side that's congruent. So we have a side, we have a 90-degree angle, which is congruent to its corresponding part, and then we have another side, which is congruent to its corresponding part. So we have side, angle, side. Side, angle, side. Angle theorem. Okay, therefore, segment AC is congruent to segment BD. Therefore, segment AC, right here, congruent, which is right here in the picture, to a BD, which is right here, and which is right here. So there's our diagonals. Ta-da! And if you notice, they ended by stating what they were trying to prove. The prove line will always be the last sentence of your proof, because that was your whole goal. Question 8 and step through it, and question 9 is extremely similar. There's two main questions that we have to ask ourselves when we're setting it up. So given that ABCD is a parallelogram and consecutive angles A and D have the measures of x and x plus 30 degrees respectively, what is the value of x? The value of x is blank. Enter the number that correctly fills in the blank of the previous sentence like this, 42. Do not include the degree symbol. Okay, first question we have to ask ourselves is, what angles are they talking about, or what side lengths are they talking about? And they are talking about angle A, x, and angle D is represented by x plus 30. So that's the first question to ask ourselves. What angle or side length are they talking about? Second question is, how are these angles or side lengths related? Well, angle A and angle D are consecutive angles, and in a parallelogram, consecutive angles add up to 180 degrees. So that's how they're connected. So their angle measures add up to 180 degrees. So angle A plus angle D is going to equal 180. So now we have to use substitution. Angle A is represented by x. Angle D is represented by x plus 30. And that equals 180 degrees. Okay, and I'm not writing the degree symbols because it's already tough enough. So we have x plus 30 equals 180. I'm going to combine my like terms, which is x and x. X plus x is 2x plus 30 equals 180. So now I need to solve for x. So in order to do that, I'm going to use the subtraction property of equality and subtract 30 from both sides. 2x had nothing done to it. 30 minus 30 is 0. 180 minus 30 is 150. So 2x plus 0 is 2x. That equals 150. Now we're going to use 2 is multiplying to x, so we're going to use the division property of equality. So divide by 2, divide by 2. 2 divided by 2 is 1. So I have 1x equals 150 divided by 2 is going to be 75. And you're asking, well, this says x, but I wrote a 1x. In math, the 1 is implied when it's multiplying, because 1 times any value does not change the value. So in math, mathematicians became lazy and just started writing x. They said, I'm tired of writing the 1. You're going to know it's implied. So 1x equals 75. So x equals 75 degrees. Well, A is 75 degrees. And D is 75 plus 30 degrees. So now question 9. Given that ABCD is a parallelogram and its opposite sides CD and AB have lengths y plus 18 and 4y respectively, what is the value of y? Okay, the value of y is blank. Enter the number that correctly fills in the blank in the previous sentence. Alright, so the first question is, what angle or sides did they give us? And they gave us CD and AB with the measures of y plus 18 and 4y. And then, how are they related? They're opposite sides of a parallelogram. Parallelograms have opposite congruent sides. So that means AB's side length equals CD. So we know that AB equals CD. And before we keep going, a thought that came in is, how do I know that CD was y plus 18 and AB was 4y? The respectively means it's listed in first, second order. So CD was the first one listed, and y plus 18 was the first one listed. So CD goes to y plus 18, and AB is the second side listed, and 4y was the second length listed. So it goes to 4y. And that's how you match it up. Okay, so we had opposite sides that were given, and their relationship is in a parallelogram. Opposite sides are congruent, which means they have the same measure, so they're equal to each other. So now we're going to use our substitution property. AB is 4y, so I have 4y equals, and CD, substitution property again, is y plus 18. Alright, and now we need to solve for y. And in order to do that, we need all of our y's on one side and all of our constants or numbers on the other. So I'm going to use the subtraction property of equality. And this is assumed to be a 1. It's a ninja 1. It's assumed there because it wasn't. Mathematicians just said if you don't see a number, it's assumed to be 1. So this is a positive 1, and subtraction, I'm going to move it to the other side. So I'm minusing 1y from the 4y because they are like terms. So 4y minus 1y leaves me with 3y. That equals 1y minus 1y is 0, plus nothing is added or subtracted from the 18. So now I have 0 plus 18, which is 18. We have 3y on the left-hand side. So now 3 is multiplying to the y, so I'm using division property of equality because it's that inverse operation of multiplication. So 3 divided by 3 is 1. 1y equals 18 divided by 3 is 6. And again, this says y. What mathematicians said if there's a 1 in front of it, it's going to be dropped. And everyone's going to know that it's just assumed there is a 1. Since you're studying math, now you know if you didn't already. So y is equal to 6. And that is how we would go through those types of questions. So ask yourself, what did they give me and how are they related?